Visit systemsarchitect.io and codeguides.io. Subscribe and like this video. In this video, we'll be discussing operational excellence in cloud systems design. Operational excellence is the running the system side of cloud design. It is a named pillar in the AWS Well-Architected Framework. Azure and Google Cloud name it in theirs too. The pillar means running and monitoring systems to deliver value. Then you continuously improve how you do it. In practice, that is automating repeatable work and learning from every failure. Automation means deployment, configuration, and recovery live in code. They do not live in one senior engineer's memory. Continuous improvement means each incident changes something concrete. Manual steps performed under pressure are where outages get longer. How a system is operated gets decided long before anyone operates it. A design only one person can deploy has built its own bottleneck. Most production incidents follow a change. Most people think most of these factors are self-determining, so how you ship is a reliability decision, not a convenience one. Automation also changes what your team can afford to attempt. When a release takes a day of manual work, you batch changes. So what does batching really cost you? Big batches are exactly what makes rollbacks hard. When a release takes 10 minutes, you ship small and fail understandably. The toil you accept this quarter is toil you still pay next year. Infrastructure as code means environments are defined in files, not clicked into a console. Terraform, AWS CloudFormation, Azure Bicep, and Google Cloud Infrastructure Manager all express that same idea. The immediate payoff is reproducibility, since you rebuild from the repository. The larger payoff is review, because a security group change arrives as a pull request. Operations as code extends the principle past provisioning. Scaling, patching, backups, and failover become automation documents rather than checklists. Configuration management tools like Ansible and Chef hold running systems in their declared state. AWS Systems Manager runbooks run those steps identically at 3 in the morning. Console changes made outside this system are called drift. Detect drift automatically, because a configuration nobody can recreate is a future outage. Version control is the foundation the rest of this pillar sits on. Application code, infrastructure definitions, pipeline configuration, and alert rules all belong in Git. That gives you history, so you can answer what changed and when. It also gives you a rehearsed rollback path, because reverting a commit is routine. What does GitOps actually change? GitOps makes the repository the single source of truth for the running system. A controller like Argo CD or Flux reconciles the cluster toward what the files declare. Deployment becomes a merge, and manual changes get corrected on the next reconciliation. Your audit trail and your deployment mechanism become the same thing. You stop asking who changed production because the answer is a commit. Continuous integration means every commit is built and tested automatically within minutes. The value is feedback speed, since a defect caught at merge costs far less. Continuous delivery keeps every build in a genuinely releasable state. Continuous deployment ships each passing build without a human gate. Pick the level that matches your risk, because payments and marketing sites differ. Build the pipeline in stages. Fast unit tests first, slower scans after. 2 metrics tell you it is working: lead time and change failure rate. Modern change management favors small, reversible changes over heavy approval gates. Feature flags separate deploying code from releasing behavior. That turns a risky launch into a toggle. Immutable infrastructure means you never patch a running server. You replace it. A new version is a new image, and the old instance is terminated. That removes configuration drift, because no server accumulates a unique history. How you introduce those replacements is your deployment strategy. A rolling update replaces instances in batches, cheap but running 2 versions at once. Blue-green runs a full second environment, so rollback is a traffic switch taking seconds. Canary sends 1 to 5% of traffic first and watches error rates. Automate promotion and roll back on metrics because an alarm beats a human watching a dashboard. The deciding question is always how fast you reach the last known good state. Observability is understanding a system's internal state from its outputs. It is usually described as three signals. Metrics are numeric time series like request rate, error rate, and latency. Logs are discrete events with detail, answering what happened in one request. Traces follow a request across services, finding the slow hop in a call chain. How is that different from monitoring? Monitoring answers whether a known condition is true. Observability lets you investigate a failure nobody predicted. OpenTelemetry is the vendor-neutral standard for emitting all three signals. Instrument deliberately, because ingest charges on high cardinality data grow fast. Correlate the signals with a shared request identifier. Site reliability engineering gave the industry its most useful operational vocabulary. A service level indicator measures something users actually experience. Good ones are latency, error rate, and availability, measured at the edge. A service level objective is the target, such as 99.9% of requests succeeding monthly. The gap between that objective and perfection is your error budget. An intact budget means ship aggressively. An exhausted one means fix reliability first. That turns a recurring argument about speed into a shared number. Alert on symptoms, so page on user-facing errors, not one instance restarting. Route every page to an incident response playbook rather than to improvisation. Every page should be urgent, actionable, and worth waking someone for. Alert fatigue is an operational failure because ignored pages eventually include the important one. Failure will happen, so the differentiator is what you do afterward. A blameless postmortem examines the conditions, not the person who made the mistake. That framing is practical because people expecting blame report problems late. Every postmortem should produce owned action items with dates. Waiting for real failures is slow, so mature teams manufacture them. A game day fails a component on purpose and watches how people respond. Chaos engineering automates that. An AWS fault injection service can inject latency on a schedule. Self-healing systems handle the common failures with no human at all. Automated remediation triggers the fix directly from the alarm that detected it. Health checks replace failed instances automatically. That removes the slowest recovery step, which is waking someone up. None of this survives without DevOps culture. The team that builds a service also owns running it. Learn more at systemsarchitect.io. Like and subscribe to the channel and follow the playlist. The clearest return is deployment speed with lower risk. Reliability improves because recovery paths are rehearsed rather than improvised. Mean time to recovery usually matters more than mean time between failures. Security benefits too, since patching by rebuilding an image is faster and more complete. Cost improves indirectly as the telemetry finding a slow endpoint finds an idle fleet. The underrated benefit is retention because engineers leave jobs full of avoidable pages. Operational tooling is a real investment, and it can be overbuilt. Blue-green doubles your environment cost, so a low-traffic internal tool wants rolling updates. Full distributed tracing on 3 services often costs more than it returns. Why not start with chaos engineering? Chaos engineering is premature before basic monitoring exists. Breaking things you cannot observe teaches you nothing. Very early products are the honest exception here. A design that changes weekly should not be frozen in Terraform yet. Start with version control, a pipeline, and alerts on user-facing errors. The signal to invest further is toil, so automate the weekly manual step next. Operational excellence is running systems through automation and repeatable practice, then improving both from what production teaches you. Its mechanics are infrastructure and operations as code, kept in version control. Small changes ship through a tested pipeline. Deployments land safely onto immutable infrastructure. And observability ties back to service-level objectives. Start with automated deployment and useful alerts. Add rehearsed failure handling and blameless review as you grow. Treat every incident as the input to the next improvement. Thanks for checking out this video. Hope you liked it and subscribe to the channel. Find a lot more articles and guides both on systemsarchitect.io and codeguides.io. Again, that's systemsarchitect.io and codeguides.io.